Welcome to this lecture on sustainable land management in agroecological zones and landscapes. I will illustrate this with three examples. One is with integrated farming systems in Cambodia. Second one will be on desertification and land degradation mapping in Mongolia. And the third one is forest management and fire management in Spain. I'm Hans-Peter Liniger from the Center for Development and Environment and the Institute of Geography of the University of Bern. I wish I could take you to the field and show you what is happening there. I try to illustrate as much as possible this lecture. Welcome. Agroecological zones. What are agroecological zones? They are geographic areas with homogeneous sets of climate parameters and natural resource characteristics, such as rainfall, solar radiation, soil types, and soil qualities, which correspond to a level of agricultural potential. So it's related to potential, it's related to climate and to the environment. The second one, agroecological zone, is a land resource mapping unit defined in terms of climate, landform, and soil, and or land cover, and having a specific range of potentials and constraints for land use, the FAO definition. So again, related to potentials or constraints, landforms, soils, land cover, climate, and it's a mapping unit, an area. Okay, we use this definition from the FAO. It's a partner of our WOCAT program, and I'm going to show you a bit more into detail what it means. It's well defined. You have the link here to the FAO website. You can look through it. I'm just shortly trying to point out these 5 different issues that they are using in order to define agroecological zones. The first one, these zones are combinations of, the first one is dominant land cover pattern. You can see on the legend, it is cropland, more than 75% cultivated land, 50 to 75% cultivated land, and then build up areas. Second line is forest, mainly forest land, and associations, land cover associations related to forest and other land uses. You can see this spelled on the forest very nicely. The third one is grass and woodland, 75%. You see the rangeland situation of in sub-Saharan Africa, very nicely, this rangeland arc. And you see grass and woodlands, which are a bit on the drier side of it. And Central Asia has some areas, and Southwest Australia. So this is definitely one of the first ones to look at, these different land cover patterns. The second one, now the legend, the terminal climate regimes. Now the legend in this one is organized in a different way. All the tropics and subtropics in the first block here, tropics, the reddish one, lowland, highlands, very important, Ethiopia, Eastern Africa, Southern Africa, and subtropics that you can see going to the Mediterranean with some rainfall in some areas, but winter rainfall in others, like the Mediterranean. And then low rainfall areas, yeah, northern Africa. Temperate zone, that whole belt here, it's very, very clear with different climate regimes from subcontinental, oceanic to continental, and then the boreal zone. So thermal climates as a second one. The third one is we go to crop suitability indexes with a certain input level here, an intermediate input level, not too high, not too low. And now crop related. So this one here as an example, so it's done for different crops, rain-fed sugarcane. And it shows where do you have a high suitability and where do you have a marginal to no suitable situation. So that's done for different crops. The next one, again, crop related, total crop production value per hectare from in dollars per hectare from very low to very high. The total crop production as another level in terms of giving an information about productivity. And the last one is the ratio of actual and potential yield. So meaning more than 85%, look at those areas here, they have only lost less than 15% of the potential of the production that they have. Whereas in these areas here, 10 to 25%, meaning they have lost around 80% of the production. They're only producing 10 to 25% of what would be possible in those areas. So these are the 5 combinations that they use for the agroecological zone mapping, also nicely shown here with these pictograms. Good, now let's go to landscape units. Before agroecological units, now landscape units. Landscape units are primarily based on, in this case here in Mongolia, I'll come back to it, primarily based on landform, slope, aspect, and elevation. You can see here mountain areas, then the foot slopes here, the lower parts of the slopes, and then the valley bottoms that you can see here. Okay, and then on top of that, each of them is subdivided into different aspects, exposition that they have towards the east, north, west, or south. In Mongolia, this seems to be important. Slope, aspect, altitude. So the basic assumptions that we have in this landscape consideration is that each of the different landscape units has a different potential. Trends and the state of the degradation should be analyzed for each landscape unit separately. We cannot mix them. They have different states and different potentials. So, and we also would have to look at it in terms of sustainable land management and then say, okay, what are the specific land management challenges and opportunities that we have in each of these landscape units? I give you another example. We go to Haiti. Now here the landscape units were primarily based on aspects. We are already in a mountainous areas, you can see very widespread, but in order to differentiate these mountain situations, we found north and south very different. All the southern slopes look much barer, degraded, than the northern slopes. So that's a pattern that we had to explain and then also consider when we look at what is the state of this land, what are opportunities for improved land management, and if you recommending or if you're implementing some improved land management practices. On the southern slopes, it's different than on the northern, because they have different potentials, different situations. Okay, another example. This looks exaggerated in the height. In Niger, these are not very high differences between a river flow here and what is called a plateau. That might be just several meters altitude difference, but it has different landscapes. The plateau here, the valley bottom is very, very different than these areas here, what is called the hill foot and the slopes. It could be also maybe 50, 60 meters altitude difference. But these have again different potentials, different constraints, and they need to be treated differently. Based on landform, slope, elevation, and soil properties. Okay, now let's look at the definitions of a landscape. A landscape is a visible feature of an area of land, of its landforms, how they integrate with natural or man-made features. Wikipedia definition. Let's look at the National Geographic definition. A natural landscape is made up of a collection of landforms such as mountains, hills and plains and plateaus. Lakes, streams, soils such as sand or clay, and natural vegetation are other features of natural landscapes. So here it's a natural landscape. And now let's look at the cultural landscape. A landscape that people have modified is called a cultural landscape. People and the plants they grow, the animals they care for, and the structures they build make up cultural landscapes. So these landscapes can vary greatly. They can be as different and as vast as cattle ranches in Argentina or the urban landscape in Tokyo. Okay. Landscapes units are defined locally, regionally, with flexible sets of criteria in order to further differentiate agroecological zones depending on problems, opportunities. Sustainable land management practices are agroecological zone and landscape specific. So, in summary, agroecological zones give a broader picture. They have larger units. They are done at the global to national level. Whereas landscape, that's when you're standing in the field and you are visually assessing and further differentiating your land depending on some criteria that wherever you are seem to be important. So the set of criteria for landscape is not everywhere the same. You define it when you're working in a certain landscape. To me, it's very important to do this. I wish we could go to the field and do it together. And when we have done this, it's a great help to assess where are the opportunities for sustainable land management improvements. Okay, let's take an example here. We go to Tajikistan, a village situation. Now, we are asked, let us look at land degradation in that area, potentials for improvements, implement good land management practices. It's a landscape, it's on a certain slope here in the mountains. It's within an agroecological zone, but we need to differentiate further in terms of landscapes. Okay, now what would you think? Here, the situation in the village compared to here, or even around the mountain where animals are grazing, are completely different. So, we differentiated that area into in-village situation with home gardens, for instance, rooftops that you can use, and near village situation, you're close to the homestead, can go work in the field and come back. This area, when I go back again, you can see there's a a valley here that is a bit of a danger to the village. So that area might just be called a protection landscape. You look at that one and treat that differently. And then this situation around here, we treat it as off village situation. Once we separated these units, these landscape units, and considered what are potentials and possible improvements, it helped tremendously. In village, near village, and off village. Completely different situations. Now, in village, for instance, water harvesting from the roofs is a clear one. You could also have home gardens that are next to the house that you would like to improve. Near village, you see very nice agroforestry, fruit tree gardens close to the homesteads that are having a very high potential and are very intensively used, high productivity, very valuable crops. And even near village situation where you take irrigation canals to that area and then have a communal irrigation situation here where you're well organized with amongst the different people in the village, and you irrigate that area and have high value crops and that. When you go then further away, off the off village situation, here water points, rotational grazing systems on that vaster landscape is very important. So here you organize the land use completely different. The options for improvements are also very different. Or that area close to the village that needs protection, there you're looking for completely different sets of land management practices to protect the village from the danger. Okay, good. Let's look at this situation. Before it was in a rather hilly environment. Now we go to a rather flat situation. Cambodia. Can you see already different landscape units in that area? Here. Rather different situation here. It's a small depression. There's water during the heavy rains, during the monsoon. The water is flowing. There's a small river here going through. So you have possibilities to harvest water here in small dams that you can then use later on for irrigation. There are possibilities for rice production here. But then you already move away from that situation into some slopes here that are a bit elevated. And that homestead situation again, close to the houses that you have, homesteads, is a completely different situation where you can plant different crops, higher value. So homestead with agroforestry, flood areas with water harvesting, ponds, bananas, rice, and slightly elevated slopes, not inundated like this place here, with food crops or secondary forest. Proximity to the ponds provides potential for irrigation. These areas close to it are used for irrigation. The land up here for this villager here, or this person land user, is too far away for irrigation. Okay, so even in a flat area, you have to differentiate because the solutions for this landscape are completely different. Okay, criteria: proximity to the homestead, infrastructure, water, slightly elevated slopes or flooded areas make a big difference. So now let's go further, not far away from this situation. Again, we remain in Cambodia. Can you see different landscapes that you would have to separate from each other? Maybe. This situation here in the foreground compared to those areas here, it's rice, flooded rice irrigation, wetlands almost situation, slightly elevated here that situation in front. It might be only 1-2 meters elevate difference in the height here, but it makes a huge difference. Here you have the possibility to have a well, to have water that is further down. Here you're actually working with flooding over a period of time during the monsoon, whereas this area here is not flooded. So you separate again the situation here into rice fields, flooded lowlands, and homestead with agroforestry, again, trees are planted here, cash crops, intensive irrigation, even through shallow wells, you have access to water. So these two situations completely different. So when you're looking for solutions, don't mix them up. Solutions here and here are a different level, on a completely different scale. Okay, and that one, for instance, also realizing proximity to infrastructure, a road provides possibility to have access to markets, and on the other hand, also off-site income. Some of the people living in close to the road have the possibility, because of infrastructure, they can go and get some income outside agriculture. That income they bring back and then invest into the land use. So you see also here, when we started differentiating this area here into these different landscapes, the search for solutions was completely different than before. And that's something that we introduced into a project here. And before, these considerations were not taken care of. And it really helped us in the analysis and the search for solutions. So the criteria here is proximity to homestead, infrastructure, water, slightly elevated slopes, or flooded river areas. That makes a difference. So every landscape in which I'm working, wherever we go, I'm differentiating into landscape units when we are searching for problems or solutions. Okay, you can go closer, look at this situation here, where you have within the farm here a diversity of different systems. But this situation here and then here is a clear boundary. This and this are worlds apart in terms of solutions and improvements that you want to make. In terms of the access to the water, how deep it is, whether it's flooded or not. Okay, and then we were looking at this situation, for instance, within one landscape specific combined practices that you have, which is called here integrated diversified farming practices, these integrated farming systems. That is very important to one land user to have a diversity from fish ponds to cash crops, fruit trees that they're having, to vegetable gardens, and access here for irrigation during the dry season. So a system that is very much integrated with different crops that he's producing. Here, this one here is showing it within one landscape unit. He could also combine it with the rice production that is in the next landscape unit. So this is an example from Cambodia. To me, again, very important that we look at the different, I go back to that, I go back to this one here, that we separate that whole landscape here into different landscape units and treat them differently. Okay, so that's it. Now we've seen the advantage. Before, there were recommendations that were coming out from a landscape and from working in this area were taken. It's not far away to this situation, and it cannot work, because here you only have the access to the water in that area and close by, and then you are elevated. You're not in the same situation like here. So looking for integrated farming systems that work well here for a land user like here are completely different than here. Okay, that's the lesson learned for in Cambodia. Now, we did that together with a whole group of different people from the land users, with students, with agricultural extension people here, and even the dean of the faculty of the Royal University of Cambodia was with us doing that work in the field. And we all learned from each other. It was great. And I hope we can do such exercises again. It's a great learning and a great experience. The farmer was with us all the time because we were talking the same things that for him are of a concern, because he is differentiating these different landscape units. He has to know in which area he can apply what kind of practice. So we always work with the land users and are very grateful for their experiences. And it was also quite an insight to see when the land user was with us, with the university students, how much we can learn from each other. Okay, so different landscapes, agroecological zones are important. You can see maybe all this is one agroecological zone. The next one is by here on the mountain, in the mountain situation. But within this agroecological zone, we differentiate further into landscapes because these landscapes matter. Okay. And the people. Not only landscapes matter, but the people as well. So we always work with the land users when we do such kind of trainings. Okay, let me switch. Now we were in intensive crop production areas, and I like to emphasize again a bit the rangeland situations because they're heavily neglected. So let's go to Mongolia. Yeah, that's the typical situation for rangeland management. Fascinating country, huge area. Most of it is grasslands, rangelands. There are some forests, we will see that. And the issue we were involved here with the Mongolian institutions was how can we assess land degradation? And then we said, okay, not only land degradation, we try to also say, okay, let's also look at what solutions would they be available. Now, when you're in a landscape like this, within an agroecological zone, how can we differentiate that area? The question was first, we have to assess land degradation. Now, what is land degradation? Very simple. It's the reduction of the potential that you have in a certain, I call it landscape unit. You have a certain potential. If everything is optimal in that area, that's your production level or your state of the system. The moment you start reducing that function and that state of that system, the land, you start degrading it. So sustainable land management always works in that direction. Try to move it to the maximum level of its natural potential that it has. So when do we make interventions? At the top here, we are realizing, hey, we are in a very good production system. Now let's not deteriorate. Other areas we've seen are going down. We keep it. We prevent it from further degrading. We maintain it. Some measures, some improvements might have to be done to do that. The second one is, you've already realized we are going downhill. Our productivity is not the same as it used to be. You can see it within one generation, you can see it between generations. Now, how can we either slow down that process, slow it down, okay, maybe stabilize it here, or if we are a bit more ambitious, we go up. We would like to reach that state. We have a potential, we are below that potential. And the third one, that's when you have reached rock bottom. That's the degradation is completely bad, severe. So how can what do you do to get out of this? We call it rehabilitation or restoration. So prevention, these are the inputs needed. Prevention, maybe the least. Then this situation from little to medium to high, depending on where you want to go. But definitely, if you're talking about restoration or rehabilitation, the input that is needed is serious to get out of that situation. So whenever we have the chance to invest money, let's make sure we are securing areas that are still very productive, have the potential, that we are not losing those ones in the next decade. So make interventions here. Then in the second one here, and maybe there's some areas where you say, yes, okay, here you go into restoration. So this is important, and you can keep that also for other assessments when we talk about land degradation. But now let's go to Mongolia. Solutions for grazing lands we need. So we said, okay, we had to define what is the state of the land. What's the potential? We had vast landscapes before, you've seen a picture before, and where do you find the situation that gives you an indication, this is the potential. Here, a fence was being built, trees were planted, so that place was taken away from the grazing, and then suddenly you see, oh, this one, trees are possible in that environment. Here you don't see any trees at all. Grasses are improving, are getting maybe different species as well. So we were looking for situations. One of them is the Trans-Siberian Railway is built through that whole landscape, and they made a fence around it to protect. They don't want to have any animals close to the railway track. So that area, that zone showed through the whole of Mongolia, showed a different vegetation with different grasses, different growth than when we went outside into the areas that were grazed. So we use such kind of situations to find out what the potential is. Now, when we look at this picture here, taken from the air, forests. Look at the patterns. Where are these forests? Does this mean these areas here that have no forest, they're degraded? Look at the landforms and the relief that you have. Here, a ridge on this side, and on this side here, forests. On that side, not. Southern slopes don't have forests. Northern slopes, it's taken that way, northern slopes here have the potential for a forest. The moment you go into plains, the forest goes. So maybe this is a question of the aspect, the exposition of those hills, where you have different potentials. Let's look at it into a bit more detail. Now, first of all, this beautiful landscape here, completely different situations. First one, valley floor plains. In terms of moisture, waterlogging even happening here, access to water, completely different. Two, what is the next one? That area. The alluvial fans here, you can still see the position of material, completely different soils, different moisture conditions. Then when we go to the next one there, the mountain slopes. And here on the mountain slopes, we already see that we have to differentiate this one here that is heavily exposed to the sun compared to that situation behind here. You see it already in the vegetation, there is a difference. But what about if you go around that mountain on the other side? We cannot compare the situation behind here to this one here, even if we are talking about mountain slopes or foot slope fans on the other side. So this was the first step that we needed. We had to differentiate these different landscape units here and treat them differently, slopes and aspects. Okay. So, identifying the potential, if you want to know what it is, it depends very much on the landscape. Once separated, it looks much easier than before. So here, already shown before, very simple zones here, looking at different aspects from east, north, west, south, and slope categories. And again, the basic assumption is that they have different potentials and they need different solutions in case we have problems in these landscape units. Okay, now our task was help, together with the partners, help to identify where do we have most land degradation in this environment. We added, and what kind of solutions can we find? So, but the first task was land degradation assessment. So taking a satellite image here, and then we had the possibility to have an infrared layer. We said, okay, let's analyze the infrared signal. It's a good indicator of cover conditions, greenness in that area. But before we started doing this, we said we need to separate this area here that we want to assess here. We need to separate it into different landscape units. So we did this. Landform, aspects, and slope. We realized in the discussions with the people, the land users, the experts in the field, we said, okay, look at all these different situations here, which we separated in terms of aspect, slopes, and in terms of steepness. That can be done using GIS methods. I'm not explaining that, so that's a task that can be done from the outside. You don't need to be in the field. And then each of these units, so let's take here, for instance, a western slope here with more than 30%. These are the dark green ones. They are spread through that whole area, everywhere. Some are closer to the main roads, to infrastructure, and to villages. Others are hidden far further away. Now we said, let's only look at one of them, each of them separately, and find out what signals in terms of NDVI. This is the NDVI signal. It's from very low to high. We get an NDVI signal. So for each of these units, we combined all the signals that we got from it and then said, okay, this might be the distribution of the signals. We take the 10% highest value that we find in one of these landscape units, 10% highest value in maybe the best protected area that has no degradation. And that to us is the reference that we will use. There we say, this is the maximum potential that unit, western slope, 30% slope, can get. Okay. And then from there, you can make it minus 20% of that signals, whatever. You can make categories of the loss of signals that you get for each point. And you can assess it. You can now look through all these areas, every unit done separately, every unit said minus 10% gives a lightish yellowish color, minus 20%, and so on. The green one shows there we have the potential. It's good. That's there. So you can make a scale and assess your whole area here, assesses, but it's landscape unit specific. And now you see the result was a bit, we were all surprised and partners liked it, we loved it, that along the valleys here where the pressure is the highest, you see the degradation as well is the highest. Animals stay here much longer than behind here where it's protected. But it doesn't matter on which landscape units these animals move around. Actually, when you have a better situation on the northern slopes, the animals try to go on that slope. So they graze the better slopes better, or the better landscapes better, more than the landscapes that have less grasses. So the pressure on that one is actually increasing. But in terms of degradation, each landscape has been treated. What is my potential and how much have I lost? And I'm not mixing and saying, oh, the southern slopes are degraded and the northern slopes, they are okay. That one was a very nice insight when we did this landscape-specific assessment. Okay, so then this was discussed. Of course, even in the field, we discussed it. We went to the governor, we passed the user associations groups, we looked at the results, what we got out, and then we did something else. We also said, okay, let's do a participatory mapping together with the people who know the area very, very well. So let's do an assessment and identify where do we have green spots and where are the darker, the reddish spots in terms of land degradation. We made a legend here and then assessed the land. And we compared that with this situation here. And that was a new insight before, because before these things, such assessments were done separately. People were using satellite images, assessed it, but they were not going to the field, were not going to the field and then discussing it with the people on there, how they assess it, and then they came up with a combined result. We went to the field and checked that situation here, a forest area that has had a forest fire, came out very nicely on our assessment here, discussed it in the field, and then said, okay, how much trust do we have if we use that map? We cannot go everywhere for the areas where we didn't go to the field. Right. Then we said, okay, still, it's just a vegetation assessment that we did first. You can have maybe the same greenness on this left-hand side, on the right-hand side. But in terms of land degradation, if you're looking at the degradation of the species, not only on the cover, but the composition. Here you have Artemisia. Artemisia, you know it also from Europe, all over the world. It's can be a native, but it can also be a nice indicator for overuse and degradation. So if you have so many Artemisia species here spreading compared to this grassland, you lose productivity because animals, most of them Artemisia species, they don't like it so much like the grasses. So greenness the same, but in terms of degradation, this is another indicator. We could also use satellite images, and we did it with the master students actually from Switzerland and the master student from Mongolia combined. They were looking at it and then said, okay, the signal and the change over the year of that area here compared to the grassland signal can be differentiated. We can find methods of remote sensing to differentiate these two situations and do a more accurate assessment, not only on cover, but on species composition. Okay, also the forest situation. We had foresters with us, and then the forest planting is also in Mongolia, for instance, to protect an area against sand and dust storms. What kind of species, what potential, how fast they grow, depends so much on the landscape units, whether you are on that slope here, the recovery of the forest is much faster than when you are in a situation like this. Why? Because you're in different landscapes. So this was a very nice insight that we got, a very nice collaboration that we had over years with Mongolian partners to assess the land degradation map. We were part of that production of a global national desertification atlas, they called it, in Mongolia. But we also were partners in looking for what kind of documenting what are good solutions for different landscape units in Mongolia. Okay, let me leave Mongolia. I come to the last example that I would like to share with you. It's on in the Mediterranean zone. If I ask you, look at this landscape here, which area is degraded? I'm quite sure at the beginning you would say, yeah, yes, this is it. This is the part here. This one here is in a much healthier state. Are we sure about that? I don't think so. Let's look first also at the potential. What soils do we have available? The slope on the northern slope, this is the soil that we have here. A darker soil, more organic matter. Here a brownish soil, very exposed to the sun here on the southern slopes. Yeah. Maybe already degraded over centuries or even more. Since the Roman times, was there once forest on both sides here? During the Roman period, we know a lot of deforestation happened and the soils degraded after that one. What is the potential for these two situations? And then, how is it in terms of land degradation? How is it in terms of solutions? So we were asking in that area, one of the issues is fire management, forest management in Spain, in a certain region here. And we looked at it and say, okay, there's some very nice forests there. Aleppo pine here with undergrowth here, but it's still used for grazing. So it is not so much firewood or dry material building up in that area. The houses are still close by. People come here with animals and graze, and some even collect firewood and remove the dead material. When you look at the landscape a bit from further away, you see this one here, very marked difference. This situation here, a bit more exposed to the south, has no bushes on it, is much a better situation. And this one here, slight change of the exposure that you have here, exposition, the aspect, and then you have a different growth here. You can even look at the back here. These were areas that were forested 20, 30, even more years ago. You can see how the forest here, not a big differentiation there is, but a slight change in the aspect here already changes, and you have forests going through, whereas these areas are a bit less covered by trees. So everywhere we looked around, we saw that differentiation. Here, in an area, they did a plantation about 20 years ago. And on that side here, there's a ridge here. You cannot see it very nicely, but there's a ridge here. On that side of the ridge, the trees had this size here. Again, this Aleppo pine. We went around the ridge, 20 meters, and we only found shrubs that looked like that. So we said, okay. They said plantation was done during the same time. Sorry, we cut the trees. We cut one each. Could take more samples, but we made arrangement with the forester of that area. So we cut that one here, this one on the southern slopes, this one here on the northern slopes. We counted the earrings here, very nicely visible, much easier to cut, much softer to cut. Then this one here was very tough, and we had to use a magnifying glass to count the rings here. We counted the same number. So planted the same time, but on land with completely different potentials. That one grew, you see the size, this one, the size. So whenever we make interventions, maybe many of them died. The density of the plants was also not so good. If you look at the recovery, we have to know about the potentials of those areas and treat them differently. Okay. Now we did an assessment in terms of fire risk in that area for a bigger landscape here, you see. And all the ones here a bit in reddish color, brownish colors, these are areas that already experienced forest fires. burned 1 time, burned 2 times, some areas even burned 3 times. These are the areas with forest fires, whereas other areas not burned. And then we did a cover assessment, and we saw that there are quite some differences on the northern and southern slopes that we have in terms of forest cover, in terms of bush cover, also shrubland cover. But then we used the same methodology that I explained before, and then did an assessment of the degradation. So, sorry, this a bit bigger, that you see the legend a bit better. And this is the same assessment that we have done in Mongolia, looking at how of each of the landscape units, how much have we lost in terms of the potential for the NDVI. The redder, the more loss of the greenness in each of the landscape units separately. And you can see closer to the valleys, closer to the village here, you can see that zone here, reddish in color. These areas that have been burned, of course, they have a different redness. But these areas here, before we had very different situations, north and southern slopes. You can see that here, north and southern. And then with this kind of assessment, it showed, yes, we reduced the potential on the northern and southern slopes with this yellow color here in the same way. Semi-degraded, very degraded, and the reference. So we also did an assessment with the WOCAT mapping, asking the people. You can see it shows some areas very nicely that coming out clearer in terms of having more degradation. Yeah, that mapping done with stakeholders. But what is not coming out clearly, a differentiation like we see it here. Can you see the lower slopes here? These areas more. That one here is not coming out so nicely. And again, we believe very much in the combination. It helps us explain the situation and find solutions. Now, in terms of fires, forest fires, you must have heard of it. Spain, Portugal, almost on a yearly basis, we have huge forest fires. Now, how do we deal with that risk? How can that be reduced? You see here, you're in which one landscape unit here, large scale planting of Aleppo pine, monoculture, you run into a problem with that one because they all grow up the same, they have the same age, they all reach maturity, they build up a lot of burning material, dry material, we call it fuel for the forest fire underneath, and then that one is not removed anymore. People go on a weekend, they go to the forest for a camping, for barbecuing, or smoke a cigarette. You drop a cigarette and that area is gone. How can we help, or how can we reduce this risk for forest fires? It can also be lightning, like this forest fire here you see. That was a lightning, and then the fire started around that tree here and burned the whole area. Now, one possibility, and we looked at it, we documented it, is prevention. How can we assure that there are not such large landscape units connected to each other? We separate them. Very important, the valley bottom is a possibility to stop the fire from jumping from one place to the other. You go on the ridges, you follow the ridges. Basically, this setup here showed that they're following landscape unit boundaries within the forest areas to separate different areas and try to avoid that if you get a fire here, it remains here and it doesn't jump to the next place. That's one on prevention. The other one would be now on restoration, what's happening after a forest fire. Natural revegetation could be something that gives the least work to do. But again, you see the difference on this aspect, again, slightly changed compared to this one here. It's rather different. So the natural regeneration here maybe if we help and you see then some species on this side is different, the moisture regime is different, the species composition. So you look at those ones and then see what kind of species do well, and maybe you can help by collecting seeds and bring those to areas that have just been burned. Okay, so let's come to the final one. Landscape matters. Agroecological zones help for broader differentiation. We have to know, are you in a wet area, in that subtropical, tropical environment, or in a Mediterranean climate? This is important. At the field level, this needs to be combined with landscape units. And those landscape units are a bit disregarded. Reading the landscape and recognizing different landscape units is central for the problem analysis, for instance, land degradation assessment, as well as finding solutions. Key. I cannot emphasize it more than enough. If we combine land and water management, which to me is a must, the next level is then a watershed landscape approach. I've not touched that now. I've not looked at the watershed situation. I'm going to do that in the next lecture that I have in 1 week's time. Okay, that's it. Now, fieldwork. I wish we could look at this in the field. Absolutely central. I'm a strong believer in it. I always take people out. We go out, land users, government officials, ministry people, foresters here in that case. We go to the field and do assessment and read the landscape properly. And one of the things is I'm very fond of being geographer. I'm very fond of looking at it also a bit from above. We need to have these two views, local details here, assessing what species do you have, but then not stay in this one, lift yourself a bit out and look at the whole landscapes. So I'm quite often using drones these days. This is the first one that I had, and it's also the first one I crashed. Okay. Coming to the conclusions. For land degradation and sustainable land management, agroecological zones and landscape matter. Agroecological zones help for broader differentiation. We have to know whether we are in the tropical environment on mountain situations or whether we are in the Mediterranean zone. At the field level, however, agroecological zones need to be further differentiated into landscape units. Reading the landscape and recognizing different landscape units is central for problem analysis, for instance, land degradation assessment, as well as for finding solutions. SLM must be landscape specific. This is a must. Another must. If you combine land and water management, the next level is a landscape watershed approach. In the following lectures, I'm going to look at that. Okay, this is very dear to me, fieldwork and capacity building. And I've always worked with masters and PhD students, involve them in local field assessment. They have a bit more energy and time to look at the details, what's happening here locally, what are the impacts of different land management practices. They have all the skills and can build up the skills on GIS, remote sensing, to use that one, being geographers, being able to look into the landscape and see the differentiation, what we've shown before, and maybe also be ready to take some risks and ready for a crash. With this, I wish you all the best, take care, and hope to see you again. Thank you very much for your attention, and I hope to see you again. All the best for the next week.